Hey, what's up, you guys? It's Smith Brothers. I'm going to take you through the last practice. This is practice, not the last practice. Who am I kidding? This is practice number 5, and this is the first time we're doing a mixed practice. So we've learned essentially 3 methods for dealing with converting to moles. We have the first one we learned, which was moles and mass, and that's the one where we use these ideas right here, where in order to calculate these problems, we have to make sure we're finding the masses using the periodic table. The next one we learned was moles and volume with that constant that when we're dealing with a gas, that we've got 22.4 liters of that gas per mole at standard temperature and pressure. And finally, the last thing we learned was moles and particles, that for every mole that we have, it's going to be 6.02 times 10 to the 23rd if we have a mole of any particle, and that particle can be atoms, molecules, Skittles. I'm obsessed with Skittles, apparently. All right, anyway, so as far as these problems, we've got 3 pages worth of problems, which is a bunch, and we've kind of got some scattered things. So what I'm going to do is I'm just literally going to go through each page. I'm also going to deal with the 2 challenge questions at the bottom. That's kind of the next step that we're going through in this class, the 2-step stuff. So let's get to number 1. Number 1, I have to calculate the moles. So I know I'm finding the moles of something, and I'm given 78.2 liters of neon gas at STP. Well, the fact that I am dealing with liters tells me that this is a volume problem, which means I'm going to be using that constant, that 22.4 liters per mole constant. So like any problem, I start with what I'm given. I'm given 78.2 liters of neon. That's all I need to start with. I'm going to set that over 1. I have to get rid of liters, which means I'm going to put my 22.4 liters down here at the bottom. And I have to remember that if I have 22.4 liters of any gas, it means that's the same as saying 1 mole of that gas, and that gas is neon. I'm going to put that right there. And I'm going to put that right there, and then again, it's just a matter of going through our process. So we are going to go ahead and cancel out liters of neon over here and liters of neon right here. We're going to set this up. Now I'm going to set this up for a few of these, and the other ones I'm just going to shortcut it. So for this one, just a quick reminder that we multiply across our T-chart first, so that's going to be 78.2. times 1 equals 78.2, and I have to get my units moles of neon, and that's going to be over 22.4, which means I've got to do a little division. I'm going to use my calculator to do my division here. And I've got 78.2 divided by 22.4 leaves us with 3.49 moles. And again, you guys, if you want full credit on these problems, I'm going to get my unit, and I'm going to get my substance of Ne, and that's what I'm going to end up circling. So my final answer is, I want to know the number of moles in 78.2 liters of neon. It's 3.49 moles in neon. Let's do the next one. Next up, again, I'm trying to find moles, this time of O2 gas at STP, if I start with 20.75 liters of that gas. So that's where I'm going to start over here. 20.75 liters is the unit that I've been given, specifically of O2 gas. I'm going to go ahead and put my set my stuff over 1. Again, I've got to get rid of liters, which means I'm going to put my constant of 22.4 liters of O2 gas down here at the bottom. My 1 mole of O2 gas up here at the top, because I want to be able to end with moles. I'm going to cancel out my units that I'm not going to use. I'm going to multiply across. So again, that's going to be 20.75 times 1 is the same as saying 20.75 moles of O2 over 22.4. If I do my division, 20.75 divided by 22.4 equals 0. And I'm going to go ahead and round this up to 9. Instead of saying 0.92, this 6 is going to make that 2 a 3. So my final answer is going to be 0.93 moles of O2 gas. And that is what I'm going to put right there. So far, so good. This time, I need to figure out how many liters of N2 gas I have if I start with 17.5 moles of that gas at STP. And again, so we start with what we are given. We are given 17.5 moles of NO2. I'm going to set that over 1. And again, I'm still dealing with a volume problem here because I have to find liters. So if I'm going to end up with liters, that means that liters has to go on top. I have to be able to cancel moles, so that 1 mole of NO2 is going to go down at the bottom. And my volume constant of 22.4 liters of NO2 is going to end up on top. Okay. I'm going to cancel out my units, so I can get rid of that. I can get rid of all of that. And now all I have to do is just multiply across. So I'm going to multiply 17.5 times 22.4. Let's go ahead and do that. So 17.5 times 22.4 equals 392. I'm going to just set that to 0, 0. And that's going to be based on my unit liters of NO2, and that's going to be my final answer for that one. I'm going to circle that. All right, number 4. Determine the number of liters, so we're staying with our volume problems, of carbon dioxide if we start out with 0.8 moles of carbon dioxide, CO2. Setting up my T-chart over 1. I've got to get rid of moles, so I've got to put moles down here at the bottom of CO2. I've got to use my volume constant of 22.4 liters of CO2 at the top. And now I'm ready to do my canceling out those units. I'm going to multiply across, which means I'm going to take 0.8 times 22.4, and that's going to leave me with 17.92. 17.92, and again, the unit I have left is liters of CO2. Fabulous. Next up. Now we're going to determine the number of molecules. Alright, so look what we did, you guys. We just switched gears here. So these first 4 problems were all about moles and volume, and we've switched gears here to now molecules and moles, which is another way of saying particles and moles, which means we're now going to be using this constant right here for this problem number 5. Okay? So we have to determine the number of molecules, so this is what we want to end with, if we're starting with 7.0 moles of FeOH2. Which means I'm going to go ahead and set that over 1. Now remember, you guys, I have to finish with molecules, which means I have to get rid of my moles. So 1 mole of FeOH2. And remember, you guys, I have to use my constant here. So this is where I'm going to use my constant. 1 mole is the same as saying 6.02 times 10 to the 23rd of any particle. So that's what I'm going to put up here. 6.02 times 10 to the 23rd of FeOH2. Now, just like anything else, we can go ahead and do our canceling. So I'm going to cancel out moles of FeOH2. Oh, hang on one second.
Please have sophomores' last names H through O to the auditorium revision screen, please. Sophomores' last names H through O, please.
Okay, so now that we've done our canceling of moles of FeOH2, now I see that I can do my multiplication across, and I'm simply going to multiply 7 times 6.02 times 10 to the 23rd. And I'm going to go ahead and do this, you guys. Again, I'm using the Texas Instruments 30XA. I like to use this calculator better because it's faster for doing exponent work, which is what I want. So I'm going to take 7.0 times 6.02. I'm going to use this button just above the 7, the EE button. I'm going to type in my exponent, 23, equals, and if I look at that, I end up with an answer of 4.21. 4.21 times 10 to the 24th, so make sure you're double checking getting that exponent right. As far as our units, our unit is, oops, I forgot to put my molecules all through this. Uh-oh, that would get me some points off. Molecules of FeOH2. Sweet? All right, good. I'll try to do better this time with my units, for sure. All right, so this time I want to know, whoops, my lead is emptying out of this pencil. There we go. I want to know how many particles I have in 6 moles of C3H8. So we know we're trying to find particles. That's going to be the last thing, our last unit. So I know I have 6.0 moles of C3H8. I'm going to set that over 1. I'm going to have 1 mole down here of C3H8. So I'll be able to cross these units out. And up at the top here, I have to have my number of particles, so that's going to be 6.02 times 10 to the 23rd particles. And I'm going to abbreviate that PART of C3H8. So now I am ready yet again to get rid of my units. And now it's just a matter of multiplying 6 times 6.02 times 10 to the 23rd particles of C3H8. So let's go ahead and do that. And again, this time, you guys, I'll go ahead and use the regular. All right, so what I've got here, I'm going to take 6 times 6.02. And remember, I have to go through the extra step with this calculator. I have to hit the second button first. Then I have to hit this. It says X1, and just above that in lighter letters, it says EE. That's the button I have to hit. The little E will pop up onto the screen. I type in 23, and then I hit equals, and what I'm left with is 3.612, and so we're just going to round that to 3.61 times 10 to the 24th, and that's going to be particles, so I'm going to abbreviate that again, particles of C3H8. So like I said, I'll jump back and forth between the two different calculators so that you can see the methods. And the next one, we have how many atoms of Cl. That's actually Cl, so this is chlorine that we are dealing with, is found in 0.25 moles. Okay, and it's likely that we're dealing with a chlorine gas here. Well, of course, I guess that's probably elemental chlorine. We'll just leave it as elemental chlorine. All right, so I start out with, I'm trying to find atoms, but I'm going to start out with 0.25 moles of Cl. Again, I'm going to set that over 1. I'm trying to cancel out moles, which means I have to put 1 mole there, and specifically that is Cl. And up at the top here, I have to put 6.02 times 10 to the 23rd atoms of Cl. And again, you guys, that's our constant. 1 mole is the same as saying 6.02 times 10 to the 23rd atoms of anything. And now it's just a matter of going through and doing our canceling. And now I can go ahead and do my math. So I'm going to take 0.25. And again, I'm using the blue calculator again, the regular 30x. So I just typed in 0.25 times 6.02. I have to hit my second button, hitting that button right above the 7, typing in my exponent, and it looks like I'm going to end up with my answer is 1.5, and I'm going to round that up to 1.51. 51 times 10, and you can see that 23 right there to the 23rd, and that's going to be based on my unit's atoms. There it is right there, of Cl. And that is your final answer. All right, good work, you guys. We just got page 1 in the books. All right, let's do page 2. Page 2, basically, a little bit of everything on page 2. So we'll spend the first few, and I'm not going to do all of these because numbers 8, 9, are the same type of problems, so I'll go ahead and just do, I don't know, let's just do number 8. And number 9 pretty much works the same way as number 8. So we're trying to determine in both of these problems the number of moles if we are given X number of molecules of another substance. So just like always, we determine the unit that we already have. So we have 2.408 times 10 to the 24th molecules of sugar. We're going to set that over 1. And because we're trying to determine the number of moles, we, of course, are going to put 1 mole at the top here because that's what we have to finish with. And down here, we're going to make sure that we have molecules because we have to be able to cancel that unit out. So 1 mole of any particles, molecules, atoms, or whatever is 6.02 times 10 to the 23rd molecules of sugar. And we'll throw that in parentheses, and that's a mole of sugar right there. And now we can cancel out this unit of sugar right here, molecules of sugar, and we're left at the top with moles of sugar. So now all we have to do, we just have to do some division here. We're going to take 2.408, and we're times, so EE to the 24th, and I'm sorry, we're going to divide by 6.02 times 10 to the 23rd, and we end up with 4. And I'm just going to go ahead and put 4.00 moles of sugar as our answer. We'll circle that. All right. And like I said, number 9 works exactly the way as number 8. We have moles. We're trying to get particles of CO2 at standard temperature and pressure. So it's basically going to be the same setup. When we're done, we'll take what's up here in the upper left-hand corner, and we'll divide that divided by 6.02 times 10 to the 23rd. Okay, now number 10, we're going back in time here. We're going all the way back to the beginning of the week, and we are dealing with trying to find moles if we are given the mass of a particular substance, and in this case, the substance is aluminum, okay? So let's go ahead and set this up as we always do. We are given 134.0 grams of aluminum, Al, as I like to call it. We're going to set that over 1. Now, we have to finish with moles, so we're going to put 1 mole on top. And what I have to figure out, how many grams of aluminum are in 1 mole. So I've got a little bit of work to do here, so I'm going to go ahead and put 1 mole of aluminum. Down here, I'm just going to go ahead and put grams of aluminum. And I have to figure out what I'm up to here. So that means I have to go to my periodic table. And if I look at the periodic table, I've got an aluminum. I've only got 1 of them. And if I look up that atomic mass on a periodic table, it's going to be 26.98 grams. And so that's the number that I'm going to fill in right here, 26.98 grams. So now I have everything I need in order to solve this problem. So I'm going to take 134. Actually, you know what I'm going to do first? I'm going to cancel out my units, grams of aluminum. And now I'm going to take 134.0 grams, and I'm going to divide that by 26.98. And when I'm done, I end up with, and I'm going to go ahead and just round this up to, that's 4.966 and a bunch of other numbers to go with it. And we're just going to go ahead and round that to 4.97 grams. Oops, that's supposed to be moles. Come on, girl. Moles of aluminum. And that is the answer I'm going to circle. Okay? So if I look at number 11, it's just the opposite. So I have to find grams this time. I've got a particular substance, SnCO3, and I'm starting with 3.5 moles. So let's go ahead and set up this one. It's going to be the opposite of the one before it. In that one, we had moles, and we had grams, and we were trying to get moles. In this one, we've got the number of moles of this substance. Now I have to find out what the mass of that substance is. So I'm going to go ahead and set up 3.5 moles of SnCO3. I'm going to set that over 1, making my beautiful T-chart. I have to finish up with grams, so I know I want grams on top, but I don't know how many grams of SnCO3 I need just yet. I've actually got to do a little bit of math, and I need 1 mole down here at the bottom of SnCO3, because now I can immediately cancel that out. Goodbye. And I have to take a second to determine what I have here. So I've got Sn, which is the chemical symbol for tin. I've got 1 of those. I've got carbon, 1 of those. And I've got oxygen. and I've got 3 of those. Well, I know that the atomic mass of oxygen is 16 times 3 is going to be 48.00 grams. I know that carbon has an atomic mass of 12.01 grams. And if I look up tin on the periodic table, I know that it has an atomic mass of 118.71 grams. So if I take the time to add those things together, I end up with 178.72 grams, 178.72 grams. And this is the quantity that I'm going to put in right here, 178.72 grams. And so now I simply have to move across my t-chart and do my multiplication. Let's go ahead and do that. So I'm going to take 3.5 times 178.72 grams, and I end up with 625.52 grams of SnCO3. And again, I'm going to go ahead and circle that. That's going to be my final answer. It's a little compact. I just ran out of room over here. I didn't give myself enough room. Now, as far as number 12, we don't need to do number 12 because we essentially just did it as far as this setup. We wanted to know the mass, if we have that many moles of that substance. And we're going to set this one up just like we did the previous one, where we have moles here and grams over here. So again, if you're not quite sure how to do number 12, just take a good look at number 11. All right, let's take a look at number 13, because we're kind of switching gears here a little bit. We've been given, we need to know what the volume in liter is if we are given this number of moles of sulfur trioxide, which is SO3, which is a gas. So we're switching gears here, and if we are looking at page 1 of this document, if you recall, we have a particular constant. So we are now looking at this constant right here because we're dealing with moles in volume. It means that we're going to have to use the constant 22.4 liters is equivalent to 1 mole of that substance. And that's any gas that we use, so it doesn't matter what the gas is. As long as we're at standard temperature and pressure, 1 mole of a gas is occupies a space of 22.4 liters. Okay, so let's go ahead now. We're working on number 13. I'm going to wait a second while that thing focuses. There it goes. And we're going to start, like always, by taking what we know and putting it to the left over here, 35.45 moles of SO3. We're going to set that over 1. And we know we're going to have to cancel out moles, so we're going to put 1 mole of SO3 down here. And we know that in a mole of any gas is 22.4 liters of that gas, SO3. And now we can go ahead and start doing our canceling. We're going to cancel U. We're going to cancel U moles of SO3. And now all we have to do is multiply across our t-chart. So let's do that. We're going to take 35.45 times 22.4. And it looks like that is going to give us a quantity of, what number is this? This is number 13. Yep, there it is. This is 794.08. And again, there's my units, liters of SO3. And that is what we are going to circle. Sweet. Let's do number 14, because number 14 is kind of the opposite of what we just did. In this one, they gave us moles, we had to find volume. Now they're giving us a volume of 20 liters, and we have to find how many moles that's going to be. So we've got 20 liters of nitrogen gas at standard temperature and pressure. So that gives us some important information. So we're going to say 20.00 liters. And nitrogen gas, you guys, that's going to be S2. So we'll just make sure we put that down, the substance. Okay, and we know we have to get rid of liters here, which means we're going to put liters right down here, and that's 22.4 liters in 1 mole of N2. Make sure I put my N2 down here as well. Go ahead and do my canceling. Canceled. Canceled. And now what I'm going to do is I'm simply going to take 20, and I'm going to divide that by 22.4. So I've got 20.00 liters divided by 22.4, And that is going to give me this nice number of, and I'm going to go ahead and take this to the, like I said, to the nearest hundredth. So I'm going to say 0.89 moles of N2. So there you go. All right, 15, we're changing gears yet again. So we're going to go back to that front page, and remember that anytime we're dealing with molecules, molecule is another way of saying it's a particle. Okay, in this case, the type of particle that it is a molecule. And what we want to know is how many molecules of H2 are there in 10 moles, which means that we have to go back to our first page and take a look at which constant we're going to use here and the constant that we are going to use for this problem, because I'm dealing with particles and moles, is going to be 6.02 times 10 to the 23rd, because remember, if you have 1 mole of any particle, you have this many. 6.02 times 10 to the 23rd, or 602 and 21 zeros of stuff. It's a lot of stuff. All right, so let's take what we have. We have 10.00 moles of H2O. We're going to set that over 1. We have to cancel out moles, so we know that's going to go down here at the bottom. Mole of H2O. And it's going to be 6.02 times 10 to the 23rd of molecules of H2O. Because we want to figure out how many molecules, that means that has to be up on top here. So we have our setup ready to go. Let's go ahead and cancel out our moles of water. And we can just do our multiplication across here. And for the sake of speed and efficiency, I'm just going to continue to use the 30XA calculator. It just makes me happy, and I like to be happy. All right, so I'm going to take 10.00 times 6.02 EE to the 23rd equals, now notice, you guys, it looks like it's the same number, but it's not. This number is 6.02 times 10 to the 24th. And that makes sense because if we look at the number 10, you know, we're gaining a decimal place there, and that's what that exponent is telling us there, that 24th. So I've got 6.02 times 10 to the 24th, and that's going to be molecules of H2O, and that is going to be the answer that I go ahead and circle. All right, good job on page 2. Guess what? It's time for page 3. Let's do it. Now, as far as page 3, we're not really covering a lot of new ground. Page 3, they mix these up a little bit more as far as which method you should be using, be it mass in moles, be it volume in mole, be it particles in moles. So just know the most important thing that you can do for yourself is to figure out what you're doing. So like 16 is going to be moles if we are given grams, which means that I need to take the time to figure out what's in this. I've got H times 2, I've got O times 1, so that's going to be 2.02, and 1 of oxygen is, 16.00 for a total of 18.02. So just know that when you see moles, and if you see a quantity of mass, which means it has the unit of grams, it means you're going to have to go through that process right there. You're going to set your stuff up the same, 36.04 grams over 1. You have to put 18.02 grams of H2O right here, H2O right here. And we know that if I have 18.02 grams of H2O, that's going to be 1 mole of H2O. And then it's just a matter of going through your process. For 17, we're dealing with liters, which tells me that I'm going to have to use my constant of 22.4 liters in this one. Again, I have grams here of iron. I'm trying to find grams, and I have 7 moles, which means I'm going to have to go through this process again where I figure out how much mass is in this quantity right here. So I've got 1 iron, I've got an O. Remember, I have to use the subscript here, which means I'm going to have 2 oxygens. I have to use the subscript on this H as well, which means I'm going to have 2 H's. So that's what you have to remember on a problem like this. Now, if you want, I'll go ahead and do this problem. So, 1 iron is 55 2.85 grams. 2 oxygens, that's going to be 32.00 grams, and 2 hydrogens, that's going to be 2.02 grams, for a total of 89.87 grams. 89.87 grams, and then it's just a matter of just setting up your problem. 7.00 moles of FeOH2. And I'm not going to do the math on this. I'm just going to make sure you know the setup. I'm going to put 1 mole of FeOH2 right here. And on top, that's going to be, of course, my 89.87 grams of FeOH2. And then again, it's just a matter of canceling and doing your work. Number 19, we have to calculate the number of moles in 7.50 times 10 to the 23rd atoms. Atoms are a particle, so I know I'm going to use that 6.02 times 10 to the 23rd constant in this problem. This one, number 20, we go back to dealing with both grams and moles. So if we're measuring out 30 grams of table salt, how many moles is that going to be? So again, 30.00 grams over 1. I know I'm going to have 1 mole up here of table salt, which is going to be NaCl. NaCl. And then, of course, you have to calculate the mass that you're going to put of NaCl down here. And you're going to do that by taking sodium, we have 1 Na. And I've rounded that up to 23 grams. With chlorine, we've got 1 chlorine, which means that that's going to be 35.45 grams. You add that up, and you're going to end up with 58.45. And that's the quantity of grams that you'll put here. Now, the ones I am going to work on, I'm actually going to work on these challenge problems for you because we haven't really talked about this yet. I have kind of warned you that we would spend some time later in the week doing these 2-step problems. And the 2-step problems are not nearly as scary as they may sound. But what you have to remember is you're going to have a little bit bigger T-chart. All right? So we want to go ahead and start with this. We have what is the mass in grams? So we know we're dealing with a molar mass problem. What is the mass in grams of 45 liters of CO2 gas at STP? Now you may say to yourself, well, wait a second, this is a molar mass problem, but I've been given mass, but I haven't been given moles. That's not a deal breaker. We have plenty of information to get us started. We just have to go through a little bit of extra steps here. So let's do this. We know, like always, we always start with the unit they give us. They give us 45.7 liters of CO gas. So that's carbon monoxide gas at standard temperature and pressure, which is good to know. We're going to set that over 1. Now, if I want to figure out this mass, I don't have a relationship between grams or mass and liters, but what I do have a relationship is what's the common thing that grams and liters have in common? It's moles. So we know moles is going to be a part of this, so we're simply going to start by setting this up saying, okay, I want to get rid of this, which means I have to have liters here. I know mole is going to be the thing that I have in common with both of these units, so I'm going to put 1 mole of CO right here. And according to the first page of our document and our notes, we know that if we are dealing with moles in a gas, a volume of gas, that we have to use this constant of 22.4 liters. And so guess what? That's what we're going to do right here. 22.4 liters. Now the good news is this. We can immediately cancel out the units here and the units here. But we're not quite ready to go yet because we're not looking to finish with moles. We're looking to finish with grams, which means we are going to add another part to a T-chart. Oh, geez, we just made our T-chart bigger, just like when we were doing dimensional analysis practice. So right now I have moles left because I was smart enough to cancel out liters pretty quickly. I did that right away. So now the only unit that's left is moles, and I have to get from moles to grams. And the good news is I know how to do that. So I know I have to set 1 mole down here of CO, and because I'm dealing with a mass, I have to figure out what my quantity of grams of CO should be here, and I already know how to do that because now what I'm doing, I started by doing a volume in mole problem. Now what I'm doing a molar mass problem, which means I have to calculate the mass of carbon monoxide I have. So I have carbon, I have 1 of those, and that's going to equal 12.01. I have oxygen, and I have 1 of those, which equals 16.00. And when I add those up together, I end up with 28.01 grams. And that's the quantity I'm going to put in here. So 28.01 grams. Now the good news is I can do more canceling. So I'm going to cancel these units here and these units here. And now I've got a little bit of work to do with this problem because now I have to do my multiplication going this way first. So I'm going to have 45 times 28.01. So I'm just going to drop down here and do this here. So I've got 45.7. And I'm going to use my parentheses because I like parentheses. Times 28.01 grams of CO over this number right here, 22.4. So let's go ahead and bust out our handy calculator, and we're going to take, now, you guys, one of the things you want to remember, when you have a quantity like this, make sure you do your multiplication first. Get your multiplication first, get your answer, and then divide that answer by whatever's underneath it. So let's do that. So we're going to take 45.7 times 28.01, and that equals this number right here. So that's going to be, and you know what I'm going to do? I am still going to round this to the nearest hundredth. So that's going to leave me, what is that going to be? It's going to be 1,280. So 1,280.06 grams of CO over 22.4. So now I'm going to, like I said, I'm going to round that. So I'm going to take 1280.06, and I'm going to divide that, divided by 22.4 equals, and then when I'm done, you can see my answer right there. It's going to be 57.1, and that 5 is going to make that 4 into a 5, so 57.15. And again, my unit is that I have left is grams of CO. And that's going to be my final answer. So again, you guys, these 3-step problems kind of feel scary, but they're not. Because all we're doing is you basically are setting up 2 problems in one. And once you solve one, then it's time to solve the other. So let's do the next one, because we're going to be doing essentially the same thing here. So I don't know how many liters I've got. I'm trying to find out how many liters I have of SO3 gas at standard temperature and pressure if there are 52.5 grams. Well, let's figure this out. Again, I'm given grams, so that is going to be where I start my problem. 52.5 grams of SO3 gas over 1. Now again, you guys, I can't go right from grams to liters, but I can go grams to moles. So I'm going to put 1 mole on top here of SO3, and I'm going to put grams of SO3 down here. And how many grams? Well, that's again something I have to calculate using my periodic table and those atomic masses. So I'm going to come over here and say, all right, I've got 1s, so s times 1 equals, and the atomic mass of sulfur is 32.06 grams. And I've got 3 oxygens according to that subscript. So I've got oxygen times 3 equals what? That's 48.00 grams. Let me just double check my work on that. Yep. And if I add those together, the mass of SO3 is going to be 80.06 grams, and that is what I'm going to put down here. So 80.06 grams. Now the good news, there it is again, is that I can go ahead and eliminate these units right now, which is awesome. So now what I have to do is, remember, I'm trying to finish up with liters. So I know liters has to go up here. Do I have a relationship between liters and moles? I most certainly do. So I can put 1 mole down here of SO3. And if you remember, if we go back to the idea, whenever we're dealing with moles and liters together, we have to use this constant right here. So if I'm dealing with liters of something, volume in other words, and moles, it means I have to use my constant of 22.4 liters. So let's do that. Put that up here. 22.4 liters of SO3. And now I can go through and cancel my units again. Now you guys notice how I'm not tackling any numbers yet. The only thing we're tackling right now is units. We'll tackle all the numbers once we get all the units taken care of. So we're going to tackle our units first. Now that we've done that, we've got the unit that we want to end with right there, liters of SO3. So now let's tackle the math. And I'm just going to come right down here. I have to multiply across my t-chart. So 52.5 times 22.4 liters of SO3 over, the only thing that really is left is this number right here, 80.06. Now, like I said before, we want to do our multiplication first. So let's go ahead and do that first. And I've got 52.5 times 22.4 equals 1,176. 1,176. I'm going to go ahead and just say 0.00. My unit is liters of SO3 over 80.06. So now I can just take that number, 1,176, and divide that by 80. And I end up with this number. It's 14.68, but I'm going to use this 8 to round that up to a 9. So my answer is going to be 14.69 liters of SO3 gas, and that is my final answer. And there you go. Did I do that right? Looks like I might have done that wrong. So that's 80 point. Let me just double check my math there. Sometimes I punch numbers in wrong. 1176 divided by 80.06 equals, yeah, I get the same thing. So who knows? I might have made a little math mistake somewhere along the way. But originally I got 14.59, but who knows? I might have written that down wrong. Anyway, but again, when you're setting this up and you have to do that, you know, like I said, these are all one-step problems up here. This is our first introduction into 2 steps. And just remember, you guys, when it comes to the common thing, if I'm dealing with volume or I'm dealing with mass, the commonality is moles. All right, so we know that we're going to be taking the time. If I can't necessarily go right from liters to grams, but I can always go liters to moles or grams to moles, and then I can use moles as it's like the little thing that brings everybody together. Look, it's holding hands with everybody, like, hey, everybody, let's get together. That's probably weird. Anyway, so that's how you do those 2-step problems. If you have any questions on this, of course, let me know, and of course, we will be talking quite a bit about this. All right, you guys, well done.